Welcome to the InduSoft SCADA Security Considerations webinar. Today the presenters will be Larry Combs from InduSoft and Stephen Miller from the Department Chair Information Systems Cybersecurity Center of Excellence from the Eastern New Mexico University in Ruidoso. The main goal for the webinar today is to discuss the concepts and the main considerations, so pretty much create the foundation regarding cyber attacks and cybersecurity, how to design systems, what kind of concepts or architectures should be taken into consideration when you're designing a SCADA system in any kind of network. And in 2 weeks from now, we will have another webinar where we will focus on InduSoft Web Studio, security system, and all the InduSoft tools available to put in practice the concepts, the recommendations that we discussed today from a conceptual point of view. So Larry will pretty much present operational and then management considerations about this topic. And Mr. Miller will provide introduction of the Cybersecurity Center of Excellence that he runs and provide an overview about the Control Systems Security Program. So having said that, I'll pass control to Larry and I'll let him start the operational considerations.
Great. Thank you, Fabio. So, as Fabio mentioned, I'm going to talk about security concerns, mostly from an IT perspective, and it's broken up into operational issues and then issues that you need to might want to consider from a management perspective. There we go. So one of the big changes that have been going on over the last few to several years is the types of connections that SCADA systems make. It used to be that SCADA systems were isolated to their own control networks. They were physically isolated. But today, if you look at a large SCADA system and even many smaller SCADA systems, they have connections to corporate infrastructure. They have connections to corporate databases. They have connections to the internet. They have wireless connections, dial-up connections, hardline connections. And one of the things that you need to do when you look at deploying a SCADA system, or if you want to look at hardening an existing SCADA system, is looking at where all the connections exist. And again, they can be in many different places and of many different types. Once you have identified all the different connections that exist, you want to disconnect any connections that are not necessary. These might be connections, again, to corporate machines. They might be connections, wireless connections. There might be connections that you used to use and maybe no longer use. So identify the connections, disconnect any unnecessary connections. If you do need to have connections to other systems, then using a DMZ or gateway to connect to those other systems is a thing that you want to strongly look at, as well as figuring out the direction of those connections, whether you allow the SCADA system to make outbound connections or whether you allow people from the outside to connect to the SCADA network itself. The best plan would be for the SCADA network to establish all the connections and have only outbound connections from the SCADA environment. Once you've removed any unnecessary connections, then you want to look at any remaining connections and do what you can to strengthen those connections. conduct your own penetration testing. Try to break into your own system. Use that information to create risk management processes so that if something happens, you have a plan to recover. For those environments where you do have a DMZ or a gateway between the control network and the some other network, whether it's the internet or a corporate network, implement firewalls, implement firewall rules, and be very specific in creating those rules and permitting connections. Avoid using blanket rules to allow sort of anyone to connect over any type of port. You want to make your rules as specific as possible to lock down your systems to the greatest extent possible. And then also look at intrusion detection systems so that once you do have things locked down, you can monitor when and if people do try to connect to your system. And we'll talk about this a little bit further down the road here in the presentation. So you want to look at the connections, remove any connections you don't need, harden connections you do have. And then you also want to look at what services or background or daemon processes are running in the environment where the SCADA applications are running. In today's world, many, if not most, SCADA applications are deployed on commercial off-the-shelf hardware, Windows boxes of all variety, from Windows Mobile and CE devices all the way up into Windows Server products, Linux and Unix-based products. One nice thing about this is that you can go buy off-the-shelf hardware, deploy your software, and have a very low, cost of entry to deploy your SCADA environment. Now, one of the drawbacks of that is that many of these systems are designed for ease of use. They come configured with email and internet and remote access. You want to go in and turn those types of things off if those are things that you're not using inside your SCADA applications. For any existing services that you do think that you want to maintain, figure out, is the benefit worth the risk if something bad happens. And then it's also very important to work with your SCADA vendor as you go through this process. The SCADA vendor may use services that from the outside looks safe to turn off, but you may actually harm your SCADA environment. So work closely with your SCADA vendor. Figure out what services should be turned off and can be turned off, and then turn those services off. Password management, again, a very key part of managing the security in any environment, whether it's a traditional IT environment or a SCADA environment. Users usually take the least painful path when trying to set up security and trying to access their environments. They routinely pick very simple passwords, and in many cases don't even set up passwords, where they'll use the default passwords that come with the firewall or the router or the systems that they're deploying. Basically that's a bad idea in every case. The system passwords are well known. Those are the first things that people use when they try to connect to your environment and try to break into your environment. There are many tools out in the world today that do password guessing and use things like dictionary works and keywords and product names. So avoid those types of things in your passwords. Always use a mix of upper and lowercase letters, numbers, and special characters. And then don't share passwords across systems. In many cases, we choose passwords that we believe are secure, and they may be secure, and then we tend to use those passwords in all of our different systems. Well, it only takes one break of the password to then allow anybody to get into all of those different systems. So different systems, different types of protocols should use different passwords so that if you do, if one password does get violated, then that's not going to harm the rest of your environment. Many people believe that because SCADA systems use proprietary protocols, then that is some form of security. Well, not really. If you look at the history of many of the protocols that people are using, Modbus, Allen Bradley, Siemens protocols, those protocols were developed many years ago. They were developed when people were connecting PLCs with a serial cable between the computer and the PLC. And they didn't have to worry about things like man-in-the-middle attacks or spoofing. Well, with the advent of Ethernet and the use of Ethernet widely throughout SCADA environments, those same protocols now are traveling over an Ethernet. Might be a hard cable, it might be a wireless, it might be some sort of dial-up or satellite connection, but the protocols haven't changed. The protocols are still basic text without any kind of encryption, without any kind of authentication, and it's very easy for someone to inject themselves in the middle, given the right access, and spoof the traffic and make it look like everything is going well, where in fact it may not be going well at all. Also, if your vendors have any backdoors into their software, make sure that they disclose those to you, and that they have security measures in place to secure and harden those interfaces as well. If your system vendor, whether it's a software vendor or a hardware vendor, comes out with security patches, then be diligent. Install those patches. Department of Homeland Security has been very aggressive in the last few years testing various environments, and the CERT organization has been very diligent in putting out alerts and notifications when they find things. And software vendors like InduSoft, if we find that there's a security issue, we release a security patch. If you go to our website, there's now a section for security patches on our website, and we put that there for a reason, because these are critical things that if you're running a critical environment, these are patches that you need to strongly consider implementing in your system. So if your system vendor or your hardware vendor delivers some patches to you and they're security related, you need to look at what those patches do and strongly consider how you deploy those patches in your environment, and in many cases the quicker the better. If you do have backdoors into your environment, you may have an interface that your vendor uses to access the environment. You may have interfaces that you use. I know of one environment where there was a remote site, and they were using wireless in the remote site. And for convenience, they just always left the wireless on, even when no one was there. And that's just advertising, that there's something there, and gives curious people reason to go and be curious and try to see if they can break that level of security. So, if you do have interfaces like that, make sure that you have strong encryption. Make sure that you're using, again, strong passwords and strong wireless keys. Turn off connections if they're not being used. Because all it takes is one connection. And it might not be a connection that is even in the SCADA environment. There may be some connection that a hacker or a threat entity makes to some other commercial or corporate system, and through there they get to your system. So you need to minimize the risk of those attacks, and again, don't allow inbound access to your SCADA environments. Only allow the SCADA systems to initiate connections, for example. Again, internal intrusion detection systems, both internal, and external. There, have been cases where internal people have caused lots of damage, as well as external people from the outside. So, implement an intrusion detection system. Many IT organizations today use these already for their commercial environments, for their email systems, their database servers, their web servers. Those same systems can be applied for the SCADA environments, looking at things like who's making what connections, what types of connections, what kind of data are they pulling, at what volume, and use an intrusion detection system, you might be able to get in front of an attack. If you do have an intrusion detection system, make sure that someone's getting notified. Make sure that you have an incident response process and procedure in place to take action when something happens. Make sure that the people who are responsible for this have the authority and necessary tools that they need to resolve and block attacks that might be happening. Perform audits. One of the best ways to protect yourself is to make sure that you know what's going on inside your environment. In many cases, because people sort of perceive the SCADA environments as being secure because they're either physically isolated or just historically they've had a culture or a perception of SCADA environments being secure, they don't worry a whole lot about, I'm going to go make this little bitty change, or I'm going to go do this. Well, that is, a big issue when you start thinking about, lots of people in there or lots of changes over time. If you look at a corporate server room environment, when you go in the room, you have to log in, you have to log out. If you make changes, you have a logbook for each server, and you have to say what you did and when you did it and who did it. Well, those same types of tools really need to be applied to the SCADA environment so that you know what's going on, and you can go back and look and figure out, well, this is what it's supposed to be. And you can go audit the system, you can go audit the network, and you can make sure that things are the way they are supposed to be. Conduct physical security surveys and assessments. Make sure that you know where issues might occur. Make sure that your environments are physically protected, that people who shouldn't have access don't have access. It's not uncommon for people in large network environments to have something like Windows Active Directory configured, and if you have a Windows account, you can log into a machine and you can log in any machine. Well, that's not necessarily a good thing when we're talking about SCADA. You want to really isolate who has access, both physically by walking up to a machine and maybe putting in a USB key or something in it that might have a virus, as well as physical access from the point of view of being able to get on a network and connect to a machine. You also want to identify and eliminate any single points of failure. Many of the SCADA systems that people are deploying are very critical to either their business or the national infrastructure. And if something fails, then that might open up a security issue, like if a router or a firewall fails and you're no longer protected. Well, that's not a good thing. So you need to make sure that you have processes in place where you don't have those single points of failure, and when you do have failures, you can quickly recover and maintain a good security profile. Don't allow the live network access. The thing I mentioned earlier about a wireless network at this remote site. Again, it was very convenient, but it also just allows people, the curious people, to want to go in and try to figure out what's behind that wireless router. Establish, tiger teams or red teams or CERT teams, whatever you want to call them, to react to issues when they occur. And these should be cross-functional teams. They should be made up of, managers and operators and IT staff and control engineers, so that you are basically looking at all aspects of your SCADA environment, all the way from how do people use it, to the IT operations side of it, to the actual control networks with the PLCs. Make sure that you fully evaluate all the different risks, and make sure you have strategies in place to, if you do find a risk or a threat, that you can then attack that and resolve any of those issues. So those sort of IT-ish operational considerations. Now we'll talk about a few management considerations, which are more tactical or strategic sort of things that from a company perspective you want to think about with respect to the SCADA security. Organizationally, you want to have clear, defined roles. Who's responsible for things like the network? Who's responsible for IT operations like patching and security? So defining those people, making sure that those people have sufficient authority to carry out their responsibilities. When you have clearly defined roles and responsibilities, when there are issues, you know who to go to, you know who's responsible, and there's not, either finger pointing or questions about who does what. There are people who know what they're doing, and they know what they're supposed to do, and when something happens, they know how to attack the issue. Documentation. Document what your network and server architecture looks like. Document the critical functions. So again, when something does happen or when you have new personnel involved, you have a good set of documentation where someone can go look and they can see how things are connected. They can see what protocols are going over what connections. They can see what systems are critical and what systems might not be critical. So again, if something happens, they can either go and address the more critical issues first. They can go and look at what's going on in the wire if they're responsible for protocols. So make sure you have good documentation about the SCADA environment so that when something happens, people know how to react and they don't make mistakes by not having all the right documentation and they go try to fix something that actually does more harm than good. Risk management. Risk management is something that we need to be thinking about all the time. Risk management starts by taking a baseline of your environment. Figuring out what are all of my risks right now. What kind of vulnerabilities might I have? And then what might I do about those if something actually happens? And then risk management is an ongoing process. There are new threats, all the time. And keeping up with those threats, subscribing to people like CERT, subscribing to various things that the Department of Homeland Security provides, so that when things happen, when new threats come out in the environment, then you can build those into your risk management processes. You can evaluate how those threats might affect your environment, and then you can do things about it. But it doesn't just lie with the control teams. Your IT organization should be subscribing to some of those same groups. They should be subscribing to things like the system and network services teams that put out various threats for operating system vulnerabilities. So you need to take all of those as a whole, create a baseline, look at what all your threat profiles are, figure out what you're going to do if something actually happened, and then have an ongoing living document of risk management so that as new threats come out, you evaluate those threats and figure out how they're going to apply to the business that you're doing. Network protection based on defense in depth. A lot of people look at, okay, I have a firewall, they can't get through my firewall, I'm protected. Well, you may or you may not be. If they do get through the firewall, then what? Well, one thing you want to consider is actually putting in different security measures at different layers inside your application, inside your environment. You might have different security layers that isolate critical control systems from each other, so that if one critical control system gets attacked or gets taken over, then that can be isolated from other critical control systems, so that someone who does potentially get in doesn't have access to all of the environment. Clearly identify what your security requirements are. Establish formal processes and procedures. Again, this is something that IT organizations have done for a long time with their commercial environments. But since SCADA and IT have traditionally been separate organizations, people building SCADA environments aren't necessarily trained in network and system security. They're trained in building control networks. So make sure you know who's in charge of security. and make sure that your teams work together such that if there is an issue, then you can deal with it. And again, this doesn't just apply to outside people. Many attacks come from the inside. So make sure that you're protected on the inside. Again, make sure people don't have the access that they don't need. If someone leaves the company, make sure you have a process in place where passwords get changed and various access levels potentially get changed. Someone may leave and you think it's nice and happy, and something happens and you've never changed the passwords and they get in, or they somehow sell your data or sell your access on the black market, and someone else gets access. So, make sure you have processes in place, both to protect you from external threats as well as internal threats. Configuration management, I mentioned this a little bit earlier with things like the audit tracking. Make sure you know what the configuration looks like. Make sure that you're managing configuration changes, and again, documenting those configuration changes. I've run into many cases where people deploy an environment, and over time it's changed and changed, and the documentation hasn't kept up, and something happens, it breaks, or they need to apply some patch, and they have to go back and try to figure out, well, what do I really have here? Well, if you maintain good configuration management, documentation and processes to begin with, then as you develop your SCADA applications and over the course of a SCADA life cycle, you will always know what the current configuration is. You will always know what type of networking, what type of protocols, what the devices are, what they do, how they support all the various critical processes. Because again, if something happens, you don't want to be scrambling to try to figure this out. You want to be proactive and maintain good documentation. Conduct routine self-assessments. Test yourself. Set up a honeypot where you go off and try to test breaking into your environment. Look at things like single points of failures. And do this on an ongoing basis. This isn't a one-time thing. When the application or when the SCADA project is developed, this is something you should be doing all the time. Again, it should be cross-functional. It should have the security folks involved, should have control people involved, should have operators involved, so that you can identify any potential issues and figure out what the cause of those issues are, and then go and implement corrective actions. Disaster recovery and backup plans. We all hope nothing bad happens, but again, hope doesn't always work well. And since many of these SCADA applications that people are deploying manage very critical processes, you need to figure out what's going to happen if there's a failure. Do you have a disaster recovery plan? It doesn't have to mean you have a hot backup. It doesn't mean that you can recover in 10 seconds or less. But what it does mean is you have a plan. You've identified all of the critical systems that get affected in the case of a failure. And you have a plan as to what you're going to do when something like a failure occurs. You have a plan. You have identified people who are responsible for all the various areas. And all the different types of things that can fail, everything from the network to the touchscreen monitors to the servers to the PLCs on the back end that are being used to implement this SCADA environment. And you have system backups so that if you do need to recover from some sort of catastrophic failure, you can. And this whole process is a top-down process. The senior management team needs to really be driving this and making sure that security is a focus within the organization. They need to be examples within the organization for security. They need to make sure that their people who they've placed in those roles, whether IT people or control people or operators, know what their roles are. They know what their responsibilities are. They know what authority they have to resolve issues, and that they're held accountable. The worst thing that can happen is to have this some process in place, and then just let things slide if they don't get done or don't get done properly. We're all humans, unfortunately, and in most cases we tend to take the easy way out. And in environments like this where people's lives are many times dependent on these systems, that doesn't work. So make sure that your senior management teams, to the extent that you can affect that at least, understand that security is an issue and that they need to be driving that downwards rather than you guys trying to drive the security models yourselves. Social engineering. We've all heard about it. If you're like me, you get emails frequently with people trying to fish information from you, whether it's your name, your address, your phone number, credit card info. Well, the same thing is going on in control networks. People are calling up and pretending to be analysts, pretending to be people from peer organizations, pretending to be people from different companies, trying to get information about your control networks, trying to figure out what do they do, how do they work, what kind of devices are you using, what kind of protocols are you using, what's your network look like. And the more information that they can gain, if their objective is to attack you, the farther they're going to be along in their goal. So be careful of that. Don't divulge information about your environment to people that you don't know. Don't divulge information about your environment to people inside your own organization who don't have a need to know. The fewer people who have the critical information, who don't need it, the better, because that's just a crisis waiting to be happen. We've all learned it from IT. People try and getting their emails hacked or credit cards hacked or identification getting hacked, and the same thing is going on in control networks. So be very sensitive to that because it is happening. So Fabio, I'll pass it back to you.
Thank you, Larry. So now I'd like to present Mr. Miller. He is Department Chair for the Information Systems Cybersecurity Center of Excellence from the Eastern New Mexico University in Ruidoso. Mr. Miller has been in the information system profession since 1966, working in different businesses, government and education sectors, including ExxonMobil Global Information Systems, Ford Tech Rep Division, where he worked as well for Univac Corporation on NASA mission control and on the Apollo, including Apollo 13 mission, Skylab mission, CRW controls, United Ways of Coastal Brains. Mr. Miller has served as a member and leader of several organizations, and recently he has developed an online computer and network security certification program, and he's currently creating a Center of Excellence for Cyber and SCADA Forensic Security. And we're very honored to have Mr. Miller co-presenting with us. And having said that, I'll make Mr. Miller the presenter and welcome him to the presentation.
Thank you, Fabio, and thanks for the opportunity to share what we're doing here at Eastern in the area of cyber and security and SCADA forensics. What I want to try to cover today, there's some contact information which I'll share later after the presentation, but the topics I want to cover is just an introduction of our Cybersecurity Center of Excellence that we're developing here at the university, and it's a collaboration with many organizations. And then go over the Control System Security Program overview, which is developed by Eric Cornelius is the Director of SCADA Cyber Forensics, the Department of Homeland Security at the Idaho National Labs. And his information is all on the U.S. CERT. And the information I'm going to cover on the overview of vulnerabilities, understanding control system, cyber vulnerabilities, and access to control system lands, discovery of process, and control of process all come from Homeland Security, and they're all on U.S. CERT. And I'll give you links to that information later. The Center of Excellence was created here about a year ago. Prior to that, our goal was to provide unique online evergreen education and training programs in IT and SCADA cyber security. And 2 years ago, we developed a computer network certification hourly program. It's 15 credit hours plus some prerequisites. If you take the prerequisites, about a 21 credit hour if you don't have prereqs. And then these are all online courses, and they're semester-based. From those, we developed a professional education, self-paced cybersecurity program. It's self-paced. It's a 12-month complete, and it's 5 different courses. And then we have a professional education, CompTIA Plus certification preparation program, which is just a single course, and we give our students 6 months to complete that particular program. These programs are developed with a steering committee that was made up of the government organizations and also private industry and academia. And so the main courses in those 2 programs, the computer network and the self-paced cybersecurity program, are based on cybersecurity fundamentals, a guide to business continuity and disaster recovery, which is based off of the InfoSec 4016 standards for risk assessment and incident response and auditing. All of these courses are based off of InfoSec 4011 through 4016 standards. If you're familiar with those are from the National Security Agency organization that sets those standards. Also, understanding the cybersecurity tools like firewalls and monitoring tools, the cybersecurity defense and countermeasures, how to take those tools and actually perform countermeasures with those tools to prevent intrusion. And then the last course is cyber ethics and professionalism. And Larry had mentioned the social networking. Our Fortune 100 company on the steering committee said one of their biggest issues in their company, in their corporation, was this whole area of ethics and understanding social networking and the impact and what to share and what not to share. So that's why that course was added, and it seems to have been a real effective. We also conduct research, development, and training in the field of IT cybersecurity. We center on meeting the private and public sector needs for infrastructure monitoring, controlling, and for training and protecting the security of the United States from enemy of cyber attacks. And some of the work we're doing with supercomputer decision support and counterattack measures, we're kind of unique in the fact that we have a direct access to the Intel supercomputer in Rio Rancho, New Mexico, and the New Mexico Application Center that helps support that through our gateway system. So we can do modeling and simulation for different types of systems. I recently finished a grant where we were doing 3D monitoring of cybersecurity monitoring tools using the supercomputer. We also utilizing SCADA and decision support artificial intelligence and knowledge-based processes in a lab environment. That's with that supercomputer as well. And we also serve as a national clearinghouse on cybersecurity in the focus of education and training based on InfoSec standards and I'm also on the committee for the National Information Cyber Education Board, which was developed in September as a shoot-off from InfoSec, and it's all part of pulling the academia and private sector and the public sector together in education, and also trying to get one single certification for all. And then research and development, best practices, process engineering and technology. And last, we provide a specialized professional services to the private and public sectors through conferences and summits, workshops, publications, and speaking engagements, much like this webinar. And you can contact me if you have a desire for us to be involved in that. Now, going forward and looking into more of the actual systems, the control system security program that we actually follow as our standard basis and what we're developing in our cybersecurity SCADA lab. We're working with the Homeland Security and Idaho labs, along with New Mexico Tech University and ExxonMobil and some other organizations that are in the control environments to help set these practices and test out the practices. And our goal is really to take those lessons learned and what's been developed in the Idaho labs and develop our students to be trained to understand and how to use the tools and know what to look for. Eric Cornelius, Director of SCADA Cyber Forensics for Homeland Security, his goal that he's put to us is that he wants us to develop the SCADA Cyber Ninjas, is what he calls them. So that's our goal. This practice, it addresses the issues encountered in developing and maintaining cyber forensics plans for control system environments. It supports the forensic practitioners in creating a control system forensic plan, and it assumes evidentiary data collection and preservation using a forensic best practices. And the goal is not to reinvent proven methods, but to leverage them in the best possible way. And the manner in which this recommended program provides users an appropriate foundation for best practices and effective control systems. And one thing I didn't mention earlier is we have developed a cyber forensics course that we're offering for the first time this semester. It's an accredited course, but it's going to evolve into that SCADA forensics class as well once we get our lab in place. This program is organized into 3 major sections, and you can actually go and look at that program off the U.S. CERT website, and that's the link at the bottom there for that white paper. But the 3 major sections are traditional forensics and challenges to control systems, then creating a cyber forensic program for control systems environments, and then the 3rd section is activating and sustaining a cyber forensics program. So this forensics program is similar to having a program that you would have for your risk assessments, your business continuity plan, your disaster recovery, incident management process as well. The vulnerabilities, control systems are vulnerable to all kinds of cyber attacks from inside and outside the control system network, as Larry had mentioned in his presentation. And to understand those vulnerabilities associated with control systems, you must know at first the types of communications that are involved in that control system, operations associated with the control system, and then understanding of how attackers are using the system's vulnerabilities to their advantage. And to discuss this discussion actually is going to provide a high-level overview of these topics, and will not really detail any of the exploits used by attackers to accomplish these intrusions, but you can go to the U.S. CERT website to get details on actual exploits if you'd like. The understanding of these vulnerabilities are associated with the control system. You have to look at the possible communication paths that are inside the control system. And this schematic I have here is just kind of a example of a potential corporate network that would have a business computing network, the internet computer network that goes out to the world internet, maybe a private telecom network, and then your control system network, and then if it's a system that is distributed. This example of my experience with Exxon Mobil was in originally 13 years with Exxon Pipeline in the SCADA area. Of course, we had pipelines all over the United States, so you have control units and communications to PLCs, RTUs all over, and so that opens up exposures there. And then, of course, the wireless networks, which most recently have been an issue and a big concern at the Idaho labs, as well as with Homeland Security, and an area that we're looking into. Again, your risk assessments, as Larry had mentioned, you look at all of these. When I worked at Exxon, we had something called a controls analysis process. We looked at the entire enterprise and then identified where the risks were, how to mitigate those risks, and based on the cost and safety and the impact to the infrastructure. Understanding these control vulnerabilities, this is just an example of a large-scale production control system and how that network would be tied to a business system, and then the firewalls that you may have in place. This is just one example. An attacker could come in through the internet. In reality, most of these are not coming in through the internet as much as they are through either internal exposures or wireless networks or exposure in the through bad passwords or email. An attacker who wishes to assume control of a control system is faced with three challenges: how to gain access to the control system network, discovery, how to gain understanding of the process itself, so that they could either close a block valve or shut down a pump, start up too many pumps, whatever, or gain control of a process. Access to that control system LAN, as Larry had mentioned, there's many ways in. The common network architectures that are used, dial-up and wireless access to RTUs and PLCs. And one of the items that I didn't really mention during the schematic, but a lot of the devices have wireless, come with wireless connectivity, so that they don't even have to go through the network to be controlled. And there have been episodes where through smartphones, a control of that device, for example, to shut down a pump or something, actually could happen without even going through the control system. Vendor support, the back doors that might be there from a vendor support. IT control communications gear. If your information systems department, how strong are their systems? Your corporate VPNs, database links, poorly configured firewalls, and then pure utility links. So all those are potential access mechanisms. The first thing that an attacker or cyber terrorist needs to accomplish is to bypass the perimeter defenses and gain access to that control system LAN. Most control system networks are no longer directly accessible remotely from the internet. The common practices in most industries has a firewall separating the business LAN from the control system LAN. And this is not only helps keep the hackers out, it isolates the control system network from outages, worms, and other afflictions that occur on the business land. Most of the attackers' off-the-shelf hacking tools can be directly applied to that problem. And there's a number of common ways that attackers can gain access to the land, and there's several miscellaneous pathways, and they outnumber the common pathways. And the second most common architecture is the control system network is DMZ off the business. A single firewall is administered usually by the corporate IT staff that protects the control system land from both the corporate LAN and the internet. And again, having that good relationship and trust, and also having audits and on those firewalls is critical. The discovery of the process, an attacker that gains a foothold on the control system land must discover the details of how the process is implemented to surgically attack it. In other words, to go in and maybe set up a scenario where they're going to try to attempt to cause in a pipeline, which is what I'm familiar with, would maybe cause a block valve to close and cause a leak and possibly explosions in a refinery, similar type of things. The two most vulnerable the attacker wants to, if it's going to be surgical, they need to know the effect. But an attacker that just wants to shut down a process, they don't really need to understand the process. They don't have to do any discovery. They can just maybe try to shut the entire system down. When I say system, the SCADA system itself. The two most vulnerable items to attack are the points in the data acquisition server database, and then the human machine interface display screens. In the data acquisition server database, each control system vendor calls the database something different, but nearly every control system assigns each sensor and pump and breaker a unique number. And on the communications protocol level, those devices are simply referred to by a number or an IP address. In the machine, so a surgical attacker needs a list of those point reference numbers to use and the information required to assign a meaning to each one of those numbers in order to go to one of those devices. Again, if it's in a wireless environment, then that device can be directly accessed and discovered. The other area that is another concern that the Idaho Labs is looking at is the bots and these bots come from the manufacturer of these RTUs and PLCs and the device and the remote unit devices that could have bots in those, and they actually can turn on and give access to the whole system or those devices. In the human interface display screens, the operator HMI screens generally provide the easiest method for understanding the process and the assignment of a meaning to each of the point reference numbers. So each control system vendor is unique in the way they store the operator screens and the points in the database. So you can set up rules in your intrusion detection system looking for files or that are affected in spotting these attackers. They can, if their access remains. And looking at sending commands directly to the data acquisition equipment, again, the easiest way to control the process is to send commands directly to the data acquisition equipment. And most PLCs and protocol converters, data acquisition servers lack even a basic authentication. And they generally accept any properly formatted command. An attacker wishing to control those simply establish a connection with the data acquisition equipment and issues that appropriate. One of the things they're going to be working with in our lab that they're doing, that they're testing at the Idaho labs, is the looking at these bots and then how they turn on and then give access to especially wireless devices to control those devices. An effective attack is to export the screen of an operator's HMI console back to the attacker. So off-the-shelf tools can perform these functions in both a Microsoft and a Unix environment. And the attacker is also limited to the commands allowed for the currently logged in operator. So as Larry had mentioned, having the strong username passwords and then having the proper controls and level of control for each operator is important. One of the things practice could be is two-factor authentication as well, in addition to the just the normal username password. RSA, as you may know, is one of those companies that provides two-factor devices. And then man-in-the-middle attacks can be performed on control system protocols if the attacker knows that protocol and he or she is manipulating. And as Larry said, there's a lot of those available. They're not that sophisticated and not that difficult for the attackers to go out and find out and discover these type of different protocols so they can do man-in-the-middle attacks. An attacker can modify the packets in transit and then providing both a full spoof of the operator HMI displays and a full control of the control system. And then by inserting commands in the command stream, then the attacker can issue arbitrary or targeted commands to the devices. And by modifying replies, the operator can be presented with modified pictures of the process so they don't even know that's going on, which happened not too long ago in a chemical company, I think in the southeast. And then direct controls from wireless handheld devices, which I've mentioned before. So that kind of wraps up some of the practices and the overview that I wanted to cover. These are my contact information. I think Fabio is going to send you that information, and also the link to the U.S. CERT control system standards, which really has a lot of good information, including what's the most recent incidents and exposures in the control environment. So I'll turn it back to you, Fabio, for any questions.
Thank you very much, Mr. Miller. All the participants in this webinar will receive a copy of those presentations. And at this point, we are almost at the end of the webinar, but I'd like to open for Q&A. If anyone has any questions, feel free to write them in the Q&A box from the WebEx webinar or even on the chat. So one question here is about the operating system, if there is any ideal operating system that's more or less vulnerable to cyber attacks.
Well, I would say from a general perspective, the Microsoft platform would be a lot more susceptible to those attacks. Linux and Unix have exposures as well, but not of the Windows environment.
I would agree to that, and part of it is the Windows environment is just a much larger threat possibility given their market share in this space. So I think all environments can certainly be disrupted, and that's why you need to take into account some of the things we talked about today.
Another question here, are there any recommended penetration threat auditing specifically for SCADA and control systems?
Well, if you look at the types of intrusion detection and penetration systems that are out there, they're mainly geared towards IT. Things like Symantec and other folks like that. There is a very good white paper on the SANS.org website, SANS, System and Network Security.org website, that has a description of various intrusion detection systems and their usages. So anybody who is interested in that, I would refer them to that. They can go spend some time on that, and there are ones out there, too numerous to try to talk about in 30 or 60 seconds, but they're out there.
Yes, and I would also say that through NIST and the National Security Agency and Homeland Security, as well as U.S. CERT, there's other. They have a list, a long list through NIST for different intrusion detection systems, monitoring systems, and even the different types of tools recommended for what types of firewalls and whatnot for different situations.
Another question is if there are any features in the InduSoft Studio to protect the SCADA against cyber attacks, and the answer is yes. In the next webinar we are hosting in 2 weeks, we'll focus pretty much on those features and demonstrating how to implement the concepts and the recommendations that we discussed today in a more practical point of view using the InduSoft Studio. So with that, I'd like to thank everybody, and especially Mr. Miller for co-hosting this webinar with us, as well as Larry Combs and everybody else who participated and promoted the InduSoft webinar. Thank you, everybody, and I hope to see you again in 2 weeks. Thank you. Bye-bye.